Hey everyone, it's Professor Sebastian. Welcome back to our statistics class notes. We are in section 6.2 talking about the normal distribution or the normal model, and we are at the top of page 87. So in this example, suppose the amount of money people keep in their online PayPal account follows a normal model. Consider these two situations. Identify whether the question asks for a measurement. In other words, does it ask for a specific value of X, which is the amount of money in the account, or does it ask for a probability, a normal probability? So a PayPal customer wonders how much money he would have to put into the account to be in the 90th percentile. This is asking for you to determine what value of X would this be, right? So this is a working backwards type situation of what I just showed you with the StatCrunch normal calculator. In part B, a PayPal employee wonders what the probability is that a randomly selected customer will have less than $150 in his account. In other words, we want the probability that X is less than $150. So this is a probability. This is the normal way of using the StatCrunch normal calculator. So quickly back to the standard normal distribution. Remember, that's the special normal distribution that has a mean of 0. Mu is equal to 0, the mean, and the standard deviation of sigma equals 1, and the total area under its curve is 1, just like every other normal distribution. It's just that the mean is 0 and the standard deviation is 1. Therefore, the standard normal distribution has z-scores on the x-axis, so those are the z-scores, okay, just as I wrote here and illustrated to you. So as a next example, let's find the probability that the z-score is greater than 2.31. In other words, we want the probability that z is greater than or equal to 2.31 using the steps outlined. So we're going to locate the value of 2.31. I found it right about here on the x-axis and draw a vertical line. Then we're going to be concerned with the area greater than z, so we're going to shade that in, the area to the right. Remember, that technically goes all the way to infinity. You can't see much area beyond 3, right? Or even right at 3, you can hardly see anything. And then we're going to use StatCrunch. Okay, so I'm going to go back to StatCrunch. Okay, now we're using the standard normal distribution. That means we've got to change the mean to be 0 and the standard deviation to be 1. Okay, so there's the mean of 0, standard deviation of 1. Now you can never change this x to be a z. You just have to understand that when you make the mean 0 and the standard deviation of 1, that means that this is now really z. And we want it to be greater than 2.31. Okay, so this is where that probability will come out. We'll hit compute, and there it is, 0.10444408, about a 1% probability. So we'll go back to, and we see that's exactly what we got. I rounded it off to 4 decimals here, 0.0104.